Hello there. Today I'm going to be giving you a quick lesson on how to read a micrometer scale. This is a 0 to 1 micrometer made by Miritoyo. It is capable of measuring across a distance from 0 to 1 inch. This particular model is capable of measuring down to within 1/10,000th of an inch, but we're just going to learn how to measure it down to 1/1000th of an inch. So if we take a 1 inch scale and we divide that into 1,000 parts, that is what we're talking about for as far as thickness. To give you a little bit of reference to that, the average piece of paper is about 3/1000ths of an inch thick. So to understand how a micrometer works, we have to take a little bit of a look at basic thread terminology. So this is a basic thread and nut, and really it's no different than the internal workings of that micrometer I just showed you. One thing we want to keep in mind is you'll notice along this threaded rod along here is that all these threads are constant, they're consistent, they're equal to each other. And if I take a thread pitch gauge, I come along here and I put that on there, you can see here that there are 11 threads per inch. That's what this little gauge tells me. So what that means is that every rotation this nut will make, or the rod will make inside the nut, in one full rotation, it is going to move one individual thread. Okay. If we do a little bit of math now associated with this, if we take one inch, divide it by 11 threads, that means that this is going to move 1/11th of an inch per rotation. I convert that fraction 1/11th into a decimal equivalent. I just put that into my calculator, 1 divided by 11. I'm going to end up with 0.091 thousandths of an inch. So for every rotation this threaded rod makes, every single one, it's going to move in 0.091 inches. To carry on with that concept of the threaded rod, inside here there is a nut and a threaded rod. The threaded rod, and I'm going to go through a little bit of terminology on the micrometer right now. The threaded rod is inside here. Okay, this threaded rod actually spins, and this is called the spindle. Okay, the spindle is connected through the inside of this and back into this rotating part, which is called the thimble. This piece out back is just a ratchet stop to make sure I don't over tighten it. I have a locking nut here. I have the frame, which is continued around here, and the anvil. So this is actually where I'm going to be doing my measuring. Okay, and you can see that as I rotate that gap closes or opens up. The other important part to look at on this micrometer is the sleeve right in around here. Okay, and the sleeve hosts or has the index line, which is this horizontal line here that runs all the way along. Okay, relating the micrometer back to the threaded rod and nut example, this micrometer and most micrometers have a thread pitch in the threaded rod and nut inside of 40 threads per inch. So if I do that same math again, and I go 1 inch divided by 40 threads per inch is going to equal 0.025, which in turn, or as we would say, is 25/1000ths of an inch. So for every rotation of our thimble, we are going to axially move the spindle 25/1000ths of an inch. You'll also notice here as I do that I'm presenting just below the index line 25 or 1 notch at a time. Okay. Transversely, you also notice that the thimble is broken into 25 increments. So what that in turn does is tells us if we only move it there, that means that I've only rotated this thimble around 1/25th of a turn. If I take how far it would move axially in one complete turn, and I take it by 1/25 of that, that is going to equal 0.001 or 1/1000th of an inch. So that is how this mic ends up measuring down to within those tolerances. I'm going to do an example measurement for you, and we'll make it fairly easy right now. We'll start right there. Okay. So on the top side of the index line, I have these numbers. These numbers indicate tenths of an inch, or 0.1, 0.2, 0.3, 0.4, and so on. So you can see that, and my initial measurement is going to be off of this particular scale. So right now I can tell that I am past 0.4. How far past? Well, I'm 18/25 of a rotation beyond that 4. So that means this measurement would be 0.418. Another example. I look at the top side here, so I'm past 0.6. And if I look below the index line, each one of these individual spaces down below here is 25/1000ths of an inch. So I'm beyond the 0.6, I'm beyond the 25, right in here. I'm beyond the 50, I'm beyond the 70/1000ths of an inch mark. And how far beyond that am I? I'm beyond 16. So what I have to do is I have to do a little addition. I add the 0.6 at the top, plus 0.075 down below, plus 0.016 for a total of 0.691. I hope this has given you an understanding of what's going on inside a micrometer, how it works, and how to do a little bit of basic addition to measure to within 1/1000th of an inch.